Hey, we are going to finish off section 10.2 today. And what we're going to look at is just a second way to do two-tailed tests. Right? So if you remember for our hypothesis testing, we've got either one-tailed test looking at it above or below, or the two-tailed test where we just say it doesn't matter. Right? So for instance, it'll look something like this. There's a claim that's been made that a population proportion, and again, this has to do with population proportions. We'll do means and other things later. So this just deals with proportions, right? So somebody's made a claim that the proportion from a population should be some number p naught. The two-sided test says that that number is just wrong. It's not bigger, it's not smaller. It is just different from p naught. Right? So here's our strategy, right? So here's how we're going to do this, right? We're going to create a confidence interval. Right? And we're going to create this obviously from the data we get, right? So we're going to create this from the sample. Right? And then the solution to reject or accept H naught is pretty easy, right? We'll say if the claim P naught is in the confidence interval, then we don't reject the null hypothesis. Right? And on the flip side, if the claim is not in the confidence interval, then we reject H naught, right, the null hypothesis, in favor of the alternative hypothesis. Okay. So, that's the idea. So the idea is not too bad, right? We'll create some type of a confidence interval here. If P naught is inside that confidence interval, we accept the null hypothesis. If P naught is somewhere outside the confidence interval, then we reject the null hypothesis. All right. So let's walk through an example here. Right. This is number 22 from our book. Right. And it's kind of an interesting little problem. Right. From the website menstuff.org. So it's got to be reputable. Right. They make a claim that says 22% of married men, and that's married, not marry, so they're not happy, they're married. Well, okay, you can be married and happy. Don't tell my wife I made this lesson. All right, so 22% of married men have, I guess, what they call strayed. Right? Whatever that happens to be. Right? So how could we test their claim? Right? Because their claim is this, right? That 22% of all men have strayed in their marriage. Right? So we'll say that P equals 0.22. We think they're just wrong. Right? So we think P is not going to be 0.22. Right? So let's make a confidence interval to test this two-tailed test. Okay? So first thing we need to do is create a sample. Right? So what we do in this particular problem is we pull out a sample of size 500. Right? So what do we know about the sample of size 500? What's its distribution? Right? Because depending on the distribution, we have different strategies for handling different distributions. Right? Normal distributions use one thing, uniform distributions use another, and so on. Right? Well, again, if you go back to our chapter 9 stuff, samples of size 500, we're hoping they have the normal distribution. So if you remember, we have those three checks that we can do. Right? First of all, are we using a simple random sample? Yep, that's what we said we were going to do here. Right? So we pull out a simple random sample of 500. So that part is done. Right? The second thing is to check this bound, n times p times 1 minus p, and make sure that it is bigger than or equal to 10. So in this case, that's 500. And remember, we're assuming that their claim is true. So we're going to assume that P is 0.22. So 1 minus P is 0.78. Right? And if you multiply all those numbers together, you get 85.8. Right? So that's a bunch bigger than 10. So yeah, so that thing checks out as well. And then the third thing is we want to check for independence. And what we talked about before was, is the sample size really small when compared to the population size? Because if the population is really big, at least much bigger than the sample, then the odds of it being independent are pretty good, right? Because if you have 1,000,000 people you're choosing from, if I pick 100 of them at random, they probably have nothing to do with each other, right? So the way we check that is we want to see if the sample size, right, little n, is less than or equal to 0.05 times the size of the population, capital N, right? So I know little n, that's told us in the problem, right? That's 500. Now, if we think about n, the number of married men that are out there, that's a really big number, right? So 0.05 means at least 20 times. So if you take 500 times 20, you get 10,000, right? So there's a lot more than 10,000 married men out there, which means we can assume that this goal is definitely going to be met, right? So based on this check, then the distribution for the samples of size 500 is going to be approximately normal with a mean of 0.22, and the standard deviation, if you remember, is the square root of p times 1 minus p over n. So in this case, that's 0.22 times 0.78 over 500. And then if we take the square root of that, we get something like 0.018526. It kind of keeps on going. Okay, so let's say 0.018526. All right, so now let's create a confidence interval based on this particular data. So if you go back to section 9.1, that's where we did some confidence interval stuff for population proportions. We saw that the confidence interval we could think of as p hat, right, the number that comes from the sample, plus or minus the margin of error, right? And the margin of error that we were using back then was just our z-score based on the size of the confidence interval, right, times the standard deviation from that statistic. Okay, so let me just remind you, again, this is on page 395 in our book, right, in section 9.1. Right? If I want a 90% confidence interval, then I use a z-score of 1.645. If I wanted a 95% confidence interval, I use a z-score of 1.96. And if I want a 99% confidence interval, I use a z-score of 2.575. Right? All right, so what we're going to do in this particular problem is we're going to make a 95% confidence interval to test the hypothesis. Right. So what that means is my z-score here is going to be 1.96. Right. So to set this up, p hat, that number that comes from our sample, well, we actually never wrote that down, but from the book, when we looked at the sample of size 500, 122 of the men there said that they did stray in their marriage. Right. So in this case, p hat, the proportion of the sample will be 122 over 500, which is 0.244. Right. So I'll have, sorry, I keep on bumping that. I just did it again. So it's 0.244 plus or minus 1.96 times the standard deviation, which we calculate to be 0.018526. And if we round all this to 3 decimal places, right, the margin of error winds up being 0.036. Right. So if I take 0.244 and add 0.036, that gives me 0.280. If I take 0.244 and subtract 0.036, that gives me 0.208, which means my confidence interval is 0.208 to 0.280. Right? So do we accept or do we reject the null hypothesis? Well, remember P is 0.22. Right? So since 0.22, the claimed value is in the confidence interval, we do not reject H naught. Which, honestly, coming from a website, menstuff.org, it was bound to be true, right? I'm sure they are a bastion of integrity in terms of their journalistic ability. Okay? All right, so that's the idea, right? To where if you have a two-tailed test, we could do the p-value process, or we could do this confidence interval process. Either way, we will get to the exact same conclusion. We either accept it or we reject it. Okay? So make sure you understand how to do both of these things. Okay? Now, one thing we do have to mention here is this, and we're not going to go over it, but we have to be careful of it. Right? So what if we have a small sample? Right, so remember the check that we're doing, the second check that we have of n times p times 1 minus p, we want that to be bigger than or equal to 10. If my sample size is small, then when we do this check, it might fail. Right? So what do we do if that second check actually fails? Right? Well, there are certain other tests out there that we just didn't have time to cover in class, right? Like we could use what's called a binomial distribution, maybe to try to answer this thing, or some other types of problems. So for our particular issues, if we run into this problem where this fails, right now we're just going to say that we can't evaluate it. Okay? There are ways to evaluate it, but we just haven't taken the time to look into all of those just yet. Okay? So make sure you do these checks, because if this thing actually does fail, if this check does fail, right, then that normal stuff that we're doing there, well, it's a bad word, normal distribution, right, it doesn't meet that criteria, which means our work is unreliable. Okay? So we just can't trust the answers that we have. All right, so here's what I want you to do. Right? There's not a whole lot of these in our section, so we just have a few of them we need to do. Look at 23 and 25, right? And then also look at 26, just to practice one of those. Right? And then at the end of the problem set, at 42, 43, 44, and 46, those are just questions to see if you really understand what's going on. Right? So you have to kind of read those problems and just interpret those results. Okay? So just a short little assignment to get us through section 10.2. We'll look at 10.3, hypothesis testing for population means next. And that'll be the last new step before our test we have coming up. Right? So if you need anything, call me. Let me help you out. Right? You're going to get frustrated with some of this stuff. Let me see what I can do to work you through it. Okay? Hope you guys are staying safe. Miss you. Talk to you later. Bye.